Okay. Yeah, so the problem before was we could just kind of eyeball it. Okay, but now we want to extend our definition, right? So let's read this question first. Let's try to understand. So we see this keyword here, normally distributed. Okay, so that's something that we can always keep in mind. And it tells me the mean is 100 and standard deviation is 10. And so anytime I see that, I'll just fill in this normal distribution graph. So we start at 100, and then each standard deviation away, that tells us the boundary of those regions. And in this case, x bar is 100, and the standard deviation is 10. Yep, good. Now it's introducing this new terminology. So Jason's mark is 115. What is his z-score? And it's really important to differentiate between a raw score and a z-score. Okay, what would you say a raw score is, Tamika?
Does that mean it's like it's in the thing?
Yeah, it's like literally what mark he got.
Yeah.
Okay, so his mark is 115. That's his raw score here. The z-score, unfortunately, they both have scores in their names. It can be a bit confusing. Remember, the z-score is the number of standard deviations away from the mean. Okay, so Jason's mark is 115. What is his z-score? So similar to that 21.5 question,
Wouldn't it be 1.5?
Yeah, but I'm going to tell you why in a second. Right?
Yeah, it is.
Is that right though?
It is right. Yeah.
But hang on, I'm confused with his raw score.
Yeah. So the raw score is telling me his mark was 115. It's just a term that they use.
So the raw score is
But that-
115.
The raw.
And then Z score is 1.5.
Yeah, Tamika.
Yeah, don't worry.
So the raw score was his mark.
Yeah, that
Okay,
makes sense.
yeah.
But you put that in. This raw score doesn't matter if you put that in there, does it?
Well, we have to use it in the
Yeah.
z-score calculation.
Okay.
So you can try and work
So
it
what
out.
are you saying that the raw? Yeah, don't get confused between the raw score and the Z.
Yeah, don't get confused between them because they're different. Right?
Oh, okay.
Yeah.
So that's okay. I get what you're saying.
Yeah.
I get it.
So yeah, Tom.
So just the raw score is just what you get in the
Yeah,
question.
that's exactly right. That's why they call it raw. Now you can try and work it out intuitively, right? But the z-score is a bit peculiar because I want you to practice using this method. So I know that z would equal to. So I look at my score that I got. So Jason's score was 115, and we subtract the mean, which was in this case 100, and I divide by the standard deviation, which was, what was that in this case? 10. Good. And that's how you get 1.5, because then you get 15 over 10, which gives you 1.5. Now, you can work that out without using this calculation, right? The problem is though, z-scores have a specific definition, because if I asked you using this definition, this is part I, I'm going to add another question. What if we had someone else's mark? Let's say Sarah got 85. What is Sarah's z-score now?
Oh my god. What is it? Booklet.
Right, so we want to use the same format, right? We want to use the score subtracted by the mean and then divided by the standard deviation. I'll show you why in a second. Okay? Because, Jacob, can you tell me Sarah's score in this case?
Give one of my thumbs up.
Is it minus 1.5?
It is going to be, but I want Jacob to do it. I want you to tell me, what is Sarah's score here?
I actually get this, I'm so pumped.
85. Okay, so we want to use the z-score definition. We want to say her score was 85, and we subtract the mean, which was 100, and we divide by the standard deviation, which is still 10. And we get negative 15 over 10, which Tom observed was negative 1.5. In this case, we get a negative. Yet the z-score is meant to be the number of standard deviations away from the mean. And that's because the z-score, if I just rub this out, has a scale. And what they say is, okay, well, if we're going above the mean, then we're positive 1 standard deviation away. And then again, if we go another standard deviation, we're positive 2 standard deviations. But now if we're going below the mean, that's when I introduce the negative z-scores. I say, okay, if I'm 1 standard deviation away from the mean, which is 100, I've got negative 1. Or if I'm 2 standard deviations away, I'm negative 2. Oh, this one, part 2. Mary has a z-score of 0. What's that?
Does that mean you got the raw score?
Of what?
100?
Yeah. Yeah, because remember, the z-score is how many standard deviations
Oh,
away.
she got the average score.
Right, exactly. So if you're saying how many standard deviations away you are, then
I like
obviously,
that.
if you got a z-score of 0, your no standard deviations away from the mean, which in this case
Oh.
is actually the mean. So a z-score of 0, I wrote this part out.
That makes sense.
So part 2, a z-score
But
of 0, yeah.
finding out the z-score doesn't give you a percentage.
It doesn't, you're right. But let me just finish this first, yeah.
That makes sense.
A z-score of 0, I wouldn't say means that she got the mean score. That's a bit confusing. A z-score of 0, so Sally, so Sarah, no, Mary. Alright. Mary received the mean.
Is this on our
Yeah.
sheet?
Yes, it is. Which was 100. So the percentages should be on there, and the z-scores as well.
On our
On your formula sheet, yeah.
I studied this for our trial. Turns out we hadn't even learned it yet.
Alright.
I didn't study it, but I just did it quickly because I was like, learn
Yeah,
my
no,
lesson
we
plan
we
lessons.
mucked up. I get it.
Yeah, you did.
Yeah. Anyway, thanks for the roast. Alright, what percentage of scores lie between 80 and 100? Now in this case, that's independent of the z-score. So usually, the z-score questions will really be mainly related to the z-scores themselves. But when we want to know the percentage of scores, we still have to come back to this normal distribution again. They go hand in hand. So what percentage of z-scores lie between 80 and 100? Well, we can use the same method we've always been doing, right? You go between 80 and 100 and you look for the percentages. What percentages do you see?
34 and 13.
Yeah, easy. So we say, okay, 13.5% plus 34%? What does that give me? Yeah, Tom?
Say that.
Can you answer this question for me first?
47.5.
Yeah, I know what you're doing. I'm just wondering with that graph,
Yeah.
is that always the same?
Yes.
So
That's the beautiful
it
thing
works-
about normal distribution.
It works for all normally, all those.
If the question says normally distributed, that means it
right.
is always this bell shape.
Okay.
Yeah.
Alright.
Okay. So
Does
what's
that change?
what's my percentage? Finish me off first.
47.5.
47.5. And yeah, Jacob.
Does it change your distribution? Like, does normally distributed change to something else?
Are you asking are there other kinds of distributions?
No.
Yes, there are, but you did not learn about them, unfortunately. But there are many
So they
different.
won't come up again.
No, they won't. I thought were you asking out of curiosity or just to be sure?
Oh, no.
In the general math course, there's only the
No,
normal distribution.
curiosity.
Yeah, but there are many other kind of beautiful distributions because, like I said, right, mathematicians they're beautiful because like we're cheaters, right? We observe things happening in the world around us. The normal distribution is just one of them, one of many. Right? I've got one more question for you.
No.